Okay, so as in the last video, we have solved MCQs till 39 from the Kips book of atomic structure, right? So today we're gonna solve atomic structure MCQs from the Kips book from 39 to 50, right? This is the very last part, which is part number 3, as you can see here the heading, right? So let's start with 39. What are they asking us in the 39th MCQ, right? So the atomic number of an element is 39. They have given us the atomic number of an element, right? And they are asking us how many electrons are there in the M shell of this element in the ground state, right? So they are asking us, this is the basically nucleus. I'm sorry, I need to use the pen here. Okay. So this is basically the nucleus here, right? This is K shell, this is L shell, and this is M shell, right? This K, L, M, right? We know that in K shell there are 2 electrons. In K shell there are 2 electrons. In K shell there are 2 electrons. In L there are 8 electrons, right? Which means here we have 10 electrons completed. Now 16 electrons are remaining. M in its ground state means M in its ground state means M plus 2, means it has lost 2 electrons, right? So how many electrons would there be? There would be 14 electrons, because we know that in the M shell there can be 18 electrons, right? But there must be 16 electrons. However, it has already lost 2 electrons, so there are 14 electrons left. So our correct option is 14, right? Let's see 40th MCQ. The electronic configuration of an element is 1s2, 2s2, 2px1, 2py1, 2px1, z1, sorry. This represents what? They have given us one electronic configuration and we need to tell what is this representing, right? So this is very, you know what, basic. We know that this represents ground state. Okay, let's read 41th MCQ, the correct electronic configuration of the copper. We have already read there is one exception in the copper, since there are 4s2 then 3d4. However, there would be 4s1, one electron would be shifted to its excited state, and there would be 3d5 then, right? So this is 41th MCQ, and we need to identify the correct electronic configuration. So let's see. Here we have 4s1, then 2 2 2 2 1. Okay, so this is correct option, right? The C not, however B, but B is not correct, since we will have the entire filled you know what, d orbital. We're gonna have 3d10 in it, right? Initially the electronic configuration was 4s2 3d9, but we know that we need to complete the d1, right? Initially copper was 4s2 and 3d9, but we know that this is wrong, right? Wrong. There was one exception, right? According to that exception, exception, the electronic configuration of this would be what? It would be, of course, 4s1, because one electron from s is gone to the excited state and it has completed d's orbital, right? So our correct answer here is C, right? C1. Okay, so 42 MCQ, which one of the following ion has similar electronic configuration like argon? We need to tell which one would be having the similar configuration as the argon. So this is very basic, titanium plus 4, which means it has lost 4 electrons, right? Then 43 MCQ, in electronic configuration of copper and chromium, which of the following is true? We need to tell which of the following would be true. So we know that 3 and D. 3D is fulfilled, right? In both the cases. Which of the following violates Hund's rule? Violates means disagree or to not to follow, right? So let me write here first because this is very basic meaning. However, no one or not everyone knows about it, right? So violate means not to comply with, not apply, not apply, right? So we need to identify the correct option for it, right? This is 44th MCQ. So here let's see which applies to it. Initially 2 electrons are gone to px, then 0 0. We know that according to 111 rule, initially this 1 electron would be gone to px, then 1 electron must be gone to py, but this has not followed this, right? So D option is correct according to this question, right? This doesn't apply the Hund's rule. 45th MCQ, which one of the following represents most stable configuration of 3 electrons for ground state of an element in group 5A? We need to identify the correct option for it, right? So as you can see, this correct according to the Hund's rule. NPX1, NPX2, Y2, not Y2, however, NPY1 or NPX1, because these all are wrong. If these 2 electrons are going to this one to this doesn't apply Hund's rule. This doesn't apply Hund's rule to this doesn't apply Hund's rule. However, it does. 1 electrons would be going to each of the shell first, orbital first, right? Now we are at our 46th MCQ. What are they asking us in it? Which one of the following electronic configuration represents an element that form a simple ion with a 3 with -3 charge? So very basic, very basic. I don't think do you guys need an explanation in it, right? A species Z has following electronic configuration: 1s2, 2s2, 2px2, 2py2, 2py2, 3s2, 3p2, 3py1, 3pz1. What could Z be? Means they are asking us atomic number of it, right? If this is given, what would be the element, right? So we need to identify. If we are going with the chlorine, right? Chlorine has, we know that 17 electrons, right? We know that it has 17 electrons. So 2 plus 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and chlorine has again gained 1 electron, right? Wait, let's check it again, right? We need to see 2, 4, 6, 8, 10, 12, 14, 15, 16, right? We know that 16 is the atomic number of sulfur, right? 16 is the atomic number of sulfur, so this is the correct option. Now 48 MCQ is the total number of lobes in all the orbitals of D. In D subshell, they are asking us about the lobes, right? They are asking us about the lobes, and we know that there are 18 lobes. There are 18 lobes, very basic, right? There are 18 lobes in the D subshell. There are 18 lobes in the D subshell. 49 and the 2 electrons in the same orbital should have opposite spins according to Pauli's exclusion principle. Pauli's exclusion principle we have discussed in very detail. Which of the following configuration is not correct according to the Hund's rule? So 2, 1, 1, 1, 1 to each orbital with the same spin is the correct. So we don't need to look to the other options. However, we have got this option correct. So today we have completed the Kips MCQs right, of atomic structure, which was very easy with all the explanations, right? So this was all for today.